Breaking news. At 04:18 UTC this morning, a routine deep space monitoring sweep detected an event that should not have been possible. Instruments tracking the interstellar object known as 3I Atlas recorded a sudden coordinated anomaly near Jupiter's orbital region, an anomaly that did not originate from the Sun, from Jupiter, or from any known natural source. Moments ago, multiple observatories confirmed it independently. The object did not merely change course, it did not fragment, it did not emit a random burst of energy. Something responded to it. At 5.2 astronomical units from Earth, near the outer boundary of Jupiter's magnetosphere, 3I Atlas triggered a reaction, precise, localized, and synchronized across multiple wavelengths. Today, the impossible just happened. This changes everything we thought we knew about interstellar visitors, passive objects, and the nature of what enters our solar system. If you want verified cosmic updates as this story unfolds, make sure to like this video, subscribe to the channel, and stay with us, because what we're witnessing may be only the beginning. To understand why this moment matters, we need to slow down. We need to establish what we know, how we know it, and why every existing model failed to predict what happened next. The confirmation did not come from a single telescope or a lone research group. It came from a network. NASA's Deep Space Network stations in California and Spain, ESA's tracking arrays in Australia, infrared data from the James Webb Space Telescope positioned at L2, optical confirmation from Hubble, and radio frequency analysis from the Atacama Large Millimeter Array high in the Chilean desert. Across 3 continents and 2 orbital platforms, the data aligned. At the center of it all was 3I Atlas. Originally cataloged as an interstellar object passing through our solar system on a hyperbolic trajectory, 3I Atlas was expected to behave like every known visitor before it, accelerate near perihelion, lose mass through outgassing, and exit the system forever.
But that is not what happened. Instead, its velocity profile began to diverge from prediction models weeks ago. Subtle at first, a deviation measured in meters per second, small enough to dismiss as observational noise. But the deviation persisted. Then it grew. By the time 3I Atlas reached the vicinity of Jupiter's immense gravitational and magnetic influence, it was already behaving in ways no comet, asteroid, or fragment of primordial debris ever has. What occurred next forced scientists to abandon the assumption that this object was passive. 48 hours before the event, analysts at Caltech flagged a mild but consistent rise in non-gravitational acceleration, approximately 0.00009 meters per second squared. That alone was unusual. There was no corresponding increase in outgassing. Spectral analysis showed no significant release of water vapor, carbon monoxide, or carbon dioxide. The surface temperature remained stable at approximately 110 Kelvin, too cold for active sublimation. 11 hours later, infrared sensors detected a faint but coherent thermal gradient along the object's longitudinal axis. Not chaotic, not uneven, directional. 6 hours before the event, a color shift was observed in the reflected spectrum, from a reddish neutral tone to a colder bluish reflectance. The shift occurred simultaneously across the object's surface, as if responding to an internal change rather than external heating. At that point, the team realized they were no longer watching a simple flyby. At 0257 UTC, as 3I Atlas crossed into the outer fringes of Jupiter's magnetosphere, radio observatories recorded a low-intensity electromagnetic disturbance measured at approximately 3.4 nanoteslas, localized in a narrow region surrounding the object. Then, at 0418 UTC, the response occurred. A brief structured radio pulse was detected. Not broadband noise, not a natural burst. The pulse lasted 1.72 seconds and repeated after exactly 11.4 seconds, then again and again. The intervals were precise, prime number precise. No known natural astrophysical process produces repeating prime number intervals without chaos, drift, or decay. Pulsars come close, but this was not a neutron star. This was an object smaller than a city, traveling through space, responding to its environment. What stunned researchers most was the directionality. The pulses were not radiating outward isotropically. They were aligned, narrowly focused toward a region just ahead of 3I Atlas, as if interacting with something invisible. Something responded. Within minutes, Jupiter's magnetosphere exhibited a localized fluctuation, subtle but measurable. Charged particle density shifted. Radio emissions from Jupiter's auroral regions briefly intensified, then stabilized.
No solar flare preceded it, no coronal mass ejection, no known trigger. The interaction appeared to be a conversation, one that physics alone could not fully explain. At Harvard's Center for Astrophysics, Dr. Elena Koren led a rapid simulation using gravitational and electromagnetic modeling. Her team input every known variable: solar wind pressure, Jovian plasma density, relativistic effects. The results were unequivocal. Under known physics, 3I Atlas should not have produced that signal, and Jupiter's environment should not have responded that way. Meanwhile, at ESA, Dr. Mark Leduc proposed a conservative explanation: an exotic natural interaction between an unusually dense interstellar object and Jupiter's magnetic field. Perhaps a rare alignment, perhaps unknown material properties. But even his own simulations struggled to reproduce the observed symmetry. On the other side of the debate, Dr. Samuel Rhee at Caltech raised more controversial possibility, not as a claim, but as a question. What if the response was intentional? That question triggered immediate internal debate. Emails circulated, encrypted channels lit up, not with panic, but with caution. Because intent is not something science assigns lightly. As more data arrived, the mystery deepened. Spectroscopy revealed faint emission lines in the radio spectrum, lines that matched no known atomic transition at the observed energy levels. The emissions were weak, but structured, clean, controlled. At the same time, optical tracking showed that 3I Atlas adjusted its orientation by 0.7 degrees, subtle but deliberate. The adjustment occurred immediately after the second pulse sequence. This was no longer random. This was no longer reactive. It was responsive. Then came the second wave. 32 minutes after the initial interaction, one section of 3I Atlas, previously thought to be a surface irregularity, vanished from all sensors. No debris, no flare, no thermal spike. One moment it was there, the next it was gone.
Mass calculations confirmed the loss. Approximately 8% of the object's remaining mass disappeared in under 0.3 seconds. And yet, the object remained stable. No known material behaves this way. At NASA's Jet Propulsion Laboratory, silence fell across the control room as the data feed updated. Analysts stared at the screen, recalculating, rechecking, refusing to accept the numbers. Because if the data was correct, then 3I Atlas was not merely interacting with Jupiter's environment. It was adapting. What followed was a synchronized event that none of the teams were prepared for. Across 3 observatories, independent instruments recorded a new pattern, a repeating sequence of electromagnetic pulses, now altered. The intervals changed, the primes shifted, as if responding to a reply. At that moment, the narrative shifted from observation to implication. Something near Jupiter, whether a field, a structure, or an unknown phenomenon, had engaged with 3I Atlas, and the object had changed its behavior in response. Governments were notified quietly. No press release, no public statement, just secure briefings and requests for continued monitoring. Satellites in Jovian orbit reported minor communication irregularities, nothing catastrophic, just enough to notice. On Earth, subtle effects followed.
A brief radio blackout over the South Pacific, a spike in geomagnetic readings over northern Canada, migratory bird flocks altered course by a few degrees, then corrected. Small things, but coordinated. As the hours passed, the narrator, watching the data scroll in real time, felt a familiar sensation return. Not fear, not excitement, recognition. We had seen this pattern before, not in space, but in our own history. The moment when observation becomes interaction, when discovery crosses into dialogue. Maybe we are not witnessing an attack. Maybe we are witnessing an introduction. In the quiet after the chaos, as instruments recalibrated and teams debated, a final observation emerged, one that has not yet been publicly addressed. 3I Atlas slowed. Not gradually, not under gravitational braking. It slowed intentionally, by exactly the amount required to remain near Jupiter. It is still there, waiting. Which raises a question we are not yet ready to answer. If something responded to 3I Atlas, what happens when it responds again? Subscribe to follow the next update, because this story is not over, and the universe may be paying attention.